Hey guys, I'm Abhay Kumar and this is AY. Have you ever questioned why the sky is blue? Maybe it's because the ocean is blue and the sky just reflects its color. In that case, the sky should be bluer at the coast or in the sea. But if you've ever been there, you know that's not true. Well, think about the question again. In the night, the sky is pitch black except the stars and the moon. So it must be because of the sun. Well, now you're getting closer to what's actually happening. This process of predicting and hypothesizing is what will get you closer to the truth, which in this case is Rayleigh scattering. About 1/3 of the sunlight gets scattered by the particles of the atmosphere, and this 1/3 is of the smaller wavelength, that is the blue region, due to the small size of the particles. Hence, the sky looks blue. But this process that you just did to find the solution to a problem is the process of science, but explained by Phil Plait, an astronomer who worked on the Hubble telescope, in his TED Talk, A Secret to Scientific Discovery. But in simple terms, this process of questioning and hypothesizing itself does a process of elimination that gets rid of all the false possibilities a problem could have. This is the basis of science. This is the foundation upon which most of the things in this world are known. The process by which all the engineering processes are formed, medicine and vaccines are produced, and even constitutional laws are made. And this is as simple as it gets. But this process itself, ironically, brings another question. Can science be wrong? Can this process of questioning and hypothesizing still lead to a wrong answer? In one of our previous videos, I talked about the discovery of phosphine on planet Venus. Since then, new reports from NASA JPL and teams at University of Washington and Georgia Tech suggest a mistake done by the previous team. Like I explained in that video, observing planets and the light coming from them, we can observe the spectral fingerprints of that light and compare them to those of molecules that we know on Earth to see what molecules are present on the planet's atmosphere. This is how phosphine was detected on Venus. So phosphine's frequency is about 260 GHz, but this study shows that the 266.94 GHz of frequency might just have been sulfur dioxide, which is very close to phosphines. So no phosphine might be there on Venus, just good old SO2, which is abundant there. So a probable mistake that made it to the headlines. Well, it's not that big of a deal. It's not like making mistakes is genetic until you bring Darwin to the table. Or at least his mistake. Charles Darwin was the one who came up with the brilliant idea of natural selection. That is the process in which every generation of population of living things change and adapt to have better traits according to their environment. But Darwin had one problem. Even after proposing the theory of natural selection, he didn't really know how it actually worked. So a few years later, he came up with the theory of pangenesis, which the word pangenesis in Greek means whole origin, which this theory was definitely not. The basic idea behind this theory was that each part of the body shed tiny particles called gemmules that are supposed to be seeds of cells, so they play part in the offspring's characteristics. To prove this theory, an experiment was conducted where one rabbit's blood was injected into another rabbit, hoping that the rabbit would show the traits of the first rabbit. But most of these experiments failed, eventually discrediting the theory of pangenesis. So a genius like Darwin made a brilliant blunder, as stated by Mario Livio in his book by the same name. But on the other side of the spectrum are the not so brilliant blunders. For that, let's go up. More up. Even more? Wait, too far, go down a bit. Perfect. This is the Hubble telescope, a space telescope that revolves around the Earth in low Earth orbit. It was launched to orbit in the year 1990 and has been snapping pictures of deep space objects since then. But when it was initially launched, it did not go as smoothly as planned. After its launch, the initial images out of it were very fuzzy. Turned out, the primary mirror on this thing had a flaw that could not be cleared out from the ground. The company that built the mirror had their equipment miscalibrated, and the mirror ended up having a defect of about 1/50th of the thickness of a human hair. 1/50th of a human hair, and the result looked like one of those UFOs are real footages. This was a stupid blunder, but to replace a huge mirror like that in space was probably impractical if not impossible. So in 1993, replacement instruments were built to compensate this flaw, which was similar to putting a pair of spectacles on a nearsighted person. And after installing these instruments, Hubble regained its normalcy and started showing photos like this. This small mistake cost NASA $700 million. But well, hey, not everyone is Einstein. Stating that Einstein never made a mistake, except that he did, but also he did not. Let me explain it to you. Albert Einstein published the General Theory of Relativity in 1915, which determines that particularly massive objects warp the space-time fabric, creating a dimple, like putting a heavy object on a stretched rubber sheet. This distortion is what demonstrates gravity. But according to popular belief at that time, Einstein too believed that the universe is static and was dissatisfied with his equation for general relativity, and introduced a cosmological constant lambda. But after astronomer Edwin Hubble's observation about an expanding universe, Einstein abandoned the constant, calling it his biggest blunder. But what even funnier is that in 1998, scientists discovered that the expansion of the universe is accelerating. That means the velocity by which the universe is expanding is increasing, which could be due to the mysterious dark energy. Scientists believe that Einstein's cosmological constant is best fit for the explanation of dark energy and its behavior in accelerating the expansion of the universe. So in the end, Einstein was correct, while also being wrong, while also being unaware of it. Okay, went in a tangent in that one. But back to the question, can science be wrong? Well, the uneducated guess would be yes, but in reality, it's a repeated process. That means that we're gonna find more wrong answers than the right ones. People have huge misconceptions about science. They think that it's just a pile of facts about stuff, but it is a fairly long process of thinking ideas and experimenting to come to a solution. We humans over hundreds of years have made lots of discoveries. But there's a lot of stuff that we don't know, and there's way lot more stuff that we don't know that we don't know. But every invention, every discovery, every milestone reached is just because us human beings like to go the extra mile in achieving something. Sure, failures come up again and again, but science is not an ideology, religion, or organization you can follow. It's not supposed to be as simple as following some pre-written rules. It is a process to push forward innovation and our own understanding of this universe that we are a tiny part of. Plus, it helps make everyone's lives better. So even if we don't know something now, chances are that we will in the future. Thanks a lot for watching, and subscribe, like and share this video, and comment about what do you think about science. And I'll see you in the next video.